Well, hello Internet and welcome to my Lua video tutorial. In this one tutorial, you're going to learn pretty much everything you could ever want to know about the Lua programming language, and in the description underneath the video I have a cheat sheet that has everything that I talk about in this tutorial, and I have a lot to do, so let's get into it. Okay, so first thing you're going to want to do is install Lua. So you can either install these binary files here. You can just go to lua-users.org/wiki/Lua binaries like that. Or if you're on Windows, you could go to code.google.com/p Lua for Windows. You can use either one of those. I am an OS X. Doesn't really matter. Everything here is going to be exactly the same no matter what operating system you're on. But you can see right here is everything you're going to need to install, and you should have no problem with that. So let's start writing some code. Okay, so on the left side of the screen, I have where I'm going to be inputting all the code, Basic Text Editor, Sublime. On the right side, I have my terminal, and if you are on Windows, this would be your command line. So let's just jump right in here, and you're going to have the extension of Lua for all of your files, and this is just luatut.lua, right like that. And let's do a hello world. So we're going to say print hello world. Just that simple. Save that, jump over here, and this is how we're going to execute our programs. Just Lua and then the name of your Lua file, and boom, hello world. So hello world is out of the way. That is how you would print to the terminal. Now you're going to be able to make comments just like this, or you can make multi-line comments like this. You can see how they popped up right there. So multi-line. And there we go. Comments are out of the way. Now your variable names can't start with a number, but they are going to be able to contain letters, numbers, and underscore. And we can just create one right like this. And basically, Lua is going to dynamically type based off of whatever you save in this variable. So this automatically becomes a string because this is a string right here. And your strings, of course, can either be double quotes or you could have them be single quotes. Doesn't really matter. Another way for you to be able to print stuff out in Lua is to go IO write like this, and you could say something like size of string, and then you could separate that if you wanted to put the string inside of here. And on top of that, let's say that we also want to get the size or number of characters in our string, so we would just put a number sign and name in this situation. And then there's going to be a bunch of things you can backslash. And this is going to be a new line like this. It's just a short, easy way for us to be able to throw a new line in here, which is just going to skip us to the next line. And there's a couple other little backslashes you can use. There's a new line, of course. You can also do a backspace. You could do a tab. Of course, you're going to need a way to be able to print a backslash inside of something like IO write. You're also going to be able to print quotes, double quotes like this, and also single quotes. And those would be used in situations in which you have double quotes here, but you want to put a double quote, let's say right here. That would allow you to do that, and we need to do this because otherwise it would not know where the string ended. And if we file save that, execute it, you can see size of string is 5. It automatically prints out for you. Now an interesting thing here is even though this is defined as a string currently, we can just as easily come in here and go name is equal to 4, like that, and that is not an error. So you'll be able to start off as a string and then convert the data or the variable over into an integer. We could then come in here and say something like my name is and name like that, and you can see my name is 4 comes out there. No errors are thrown. Other programming languages would throw errors, however. Now Lua only has floating point numbers, or what they call just simple numbers. And the biggest integer that you could store inside of Lua is this gigantic guy right here. And if we can go and add 1 to that, you're going to see that indeed that is true. So let's go and try to print one more than what we have there with big num like this. And you can see it comes back out as a negative number. So this is as big as it gets in regards to integers. You could easily come in here and then check the type of this variable by just surrounding it with type and calling the function type. Jump over here and you can see big number prints out there and number prints out right there. So you can see that everything, integers or floating point numbers, are all considered just basic numbers inside of Lua. Now, as we all know, floating point numbers, or as some of us know anyway, floating point numbers are not necessarily precise. So let's come in here and check the precision. Basically, with a floating point number, you're going to have your digits be precise up to 13 digits. So that just means like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that. And then we could come in and add another digit to it. So let's just throw in 12 zeros and then tack 5 onto the end of it and float precision. And you can see that it is precise indeed right to that point. If, however, we tacked on another additional digit onto there and reran that, you're going to see that it lost precision. So your floating point numbers are precise up to 13 digits, which is normally more than enough. Now let's say that we wanted to come in here and create a string that is going to go over multiple different lines, and at the same time also keep any white space that you would type inside of here. You would just put those two opening brackets like that, and you can type in I am a forever, right like this, and you're going to see if we run this, that it's going to not only print out the whole entire string, but also pay attention to any white space and any new lines that would occur within that long string. Let's go in here and throw in another string. There's my name. If you wanted to combine or concatenate strings inside of Lua, we could just go long string like this is equal to, and let's just use long string here. You would just put 2 dots inside of there and name. Take that, throw that in here instead. And you can see that it went in there and automatically tacked on the other string just with this little operator that we have right there. Just so that we can cover other data types that are available. We also have booleans. So able to drive, let's say we wanted to monitor that, and a boolean is going to either allow us to use a value of true or a value of false. And of course we could come in here and also check the type of this. So is able to drive like this. You can see it comes back as Boolean. And another thing that's a little bit odd about Lua, it doesn't go out of its way to try and show you errors. So let's come in here and let's try and get a type of made up variable. So made up variable has been basically just created right there in that line. It's not been defined with any value. And you're going to see right here that everything in Lua by default gets the value of nil if it does not get a value assigned specifically by you inside of your code. So there's a rundown of a lot of what you need to know about variables. Now let's go and take a look at some math functions. Okay, so basic math functions we have in Lua, we can add, subtract, multiply, divide, and this is the modulus. And let's just go ahead and save that and execute it, and you're going to see exactly the results we're able to produce here. Just pay attention that this is a modulus operation right here and not what is commonly known as a remainder operator. If it was a remainder operator, it would actually give the value of 2.2, and this just is the remainder of a division by 3. So what it does is automatically cuts that off. Just make you aware of that. Everything else here is pretty straightforward in regards to this basic mathematic operations. It's also important to know that you cannot perform common shorthand notation, like let's say we had number plus plus. Can't do that. You can't do negative negative, and of course if you can't do those, you're not going to be able to use this or this. Just common things that are in other languages that Lua does not have currently. And this is version 5.3 of Lua, so it's the most current, at least as I'm speaking right here. Another thing you can't do is this type of short notation, which is normally equivalent to number is equal to number plus 1. If you want to do this inside of Lua, you are actually going to have to instead type that out. There's a whole bunch of built-in math operations inside of Lua. These are some of the most common ones that you're ever going to see. See right here, we have floor, ceiling, max, min, sine, cosine, da-da-da-da-da. And I'll show you some examples of how all of those work. Here's a whole bunch of math functions. We're going to check the flooring, the ceiling, the max, minimum, power, and square root to see exactly how all of those operate. The only difference between floor and ceiling is the floor is going to round this number down, ceiling is going to round it up. And you can see here, max is going to give you the maximum, min is going to give you the minimum, and there's power and square root functions as well. Something that's rather neat is using random numbers, and you will probably use random numbers a lot in your programs. Let's go in here and generate a random number right now. So let's just go IO right, and you would do that with math.random, right like this. And let's say that we want to come in here and generate a random number between 0 and 1, random, and that is all that we would do. But that's a little bit boring. You may also have noticed here there's no semicolons at the end. You could put semicolons in there, but they are not needed in any way. Let's go instead and create a random number between 1 and 10. You just come in here, type in 10, and then you could also come in here and also define random numbers in very specific ranges. So let's say we wanted to go random number between 5 and 100. There you go, 5 and 100, 5 and 100. And if you see, if we execute those, they all work pretty simply. Another thing that is kind of useful is we're going to be able to set our seed value, and that is just going to help us calculate a random value. And how we do that is just go math random seed, and the best way to do that is to use os.time, right like that, and that is going to generate for us a nice random value. Another thing that is interesting is we can come in here and print our float values in other ways. So let's just use print. I'm going to be bouncing around a lot just to show you all the different ways we can use these things. If we wanted to format a string, we just go string format, and let's say that we wanted to get pi is equal to, and then we wanted to import directly into our string a value, and let's say that we wanted it to be 10 decimal places long. F for float, right like this, and we could also get the value of pi by calling the math library, right like this. You're going to see that we got the value of pi to 10 digits automatically sorted out for us. Also, however, be aware that this is only going to have a precision of 13 digits. Anything over that, and it's going to start botching itself up. And that's just the way floating point numbers work in almost every programming language. Okay, so now that we got the math functions out of the way, let's take a look at conditionals. Okay, whenever we're using conditional statements, we're going to have relational operators as well as logical operators, and the relational operators are going to be greater than, less than, greater than or equal to, less than or equal to. This is the funky one. Well, that's fine, that's just equal, but not equal is actually going to be tilde and equal to. Very important to remember that, just tilde and equal to. This one right here, which you may be aware of, is not used. And then your logical operators are going to be and, or not, spelled out exactly like that. And I'm going to demonstrate how all of these work. So let's say you have an age, which is equal to 13, and let's take a look at if statements and how they work. Now we're going to be able to perform certain operations depending upon the value of age here. We're going to say if age is less than 16, then make sure you put the then inside of there. You're going to see it automatically indents. We're going to say write, and something like you can go to school. Another thing to be aware of is any variable that we would define inside of our if statements, for statements, functions, so forth and so on, are what are called local variables. And that just means that they are local to this if statement, and the value that is set here cannot be found outside of the if statement. More on that here in a second. Now, if this if statement doesn't come back as true, maybe we want to check something else. So we would go else if, right like that, no space between there. And then we could say something like age is less than or equal to 16. And let's say that we want to check a couple things. Well, this is where our logical operators come in. We can say and we could check another one. Age is less than or equal, let's just make it less than 18, like this. Then make sure we put our then statement in there. And then we can come in here and print something else out. So we could say something like you can drive. And then finally, as a default, we would use else. Throw something else in there, and you could say something like you can vote. Another thing that we have to remember is anytime we have an if statement, we always want to use end there whenever it is finished. Now let's jump back to this guy as well as also check out exactly what goes on here. If we would go print like this, and we would go local variable, you're going to see what happens here. Let's load this. You can go to school, but this comes back as nil. Like I said, once you define a variable inside of here, a local variable, this is inside of the if statement, and it cannot be accessed anywhere outside of the if statement. And we're going to see more about that later on. Just wanted to make you aware of it. Now we come in here and play around with logical statements a little bit more, just so we can check out how all of them work. Say we want to check if age is less than 14. And we could use or, which is going to give you a value of true, and then operate with whatever is after the then statement if one or the other of these is true. You could say age is greater than 67, like this. And you could just keep on going. You could go IO, right, like this. Just keep typing. Everything's going to work. You could say like you shouldn't work, and then we could continue on the same line and then end. And don't forget to come in here and put an age in like that, and come up here and execute it, and you can see you shouldn't work comes back because 13 is the value right here. This comes back as true, which means that we're going to print you shouldn't work out onto the screen. Now you can do this, but it kind of gets sloppy, so watch out there. Just wanted to demonstrate how the logical operator works and also make you aware that you may see people use really sloppy long statements like that. Now we're going to also be able to come in here and format or convert from multiple different variable types to other different variable types. So let's just come in here and go print and string and then use format again. And I'm going to demonstrate the not logical operator as well. So let's say not true. What will that do? Well, I'm going to come in here, and if you want to put a string inside of here, you would just put a % and an S like that. However, we're going to have to convert our boolean to a string, and how we do a cast or a conversion to a string. You can throw anything inside of here, throw a number or whatever, and you can see right here the not true part right there. And if we save that, you can see that not true, this logical operator before the value of true is going to give us a value of false. And you can also see how the boolean value, this guy right here, was converted to a string, so we could use it inside of our print statement. Now there is no ternary operator inside of Lua, and a ternary operator normally looks like something like can vote is equal to age greater than 18, like this, and otherwise false. That's what a ternary operator looks like in other programming languages. And it basically just says if age is greater than 18, we want to assign the value of true to the variable can vote. Otherwise, we want to assign the value of false to the variable can vote. So we can't do that. However, we can pretty much knock it off inside of Lua. How we would do that is go can vote is equal to, and we could go age is greater than 18 and true or false. So it looks very similar to the ternary operator, and it works exactly like the ternary operator. And we could say can I vote, and we can come in here and go to string again and can vote. Let's change this to can vote. And you can see right here the answer comes back as false. So there's an example of how we can use conditional statements, or if, else, and else, as well as knock off a ternary operator. And it's also good to know that there is no such thing as switch inside of Lua, but you can also basically knock that off with if and else statements. Now let's go and take a look at some strings and ways that we can work with them. Okay, so I went and created a really long string right here for us to be able to play around with, and I'm just going to do a couple simple little string operations that are common, and then as the tutorial continues I'll cover some more. So let's go and say that we wanted to do something like get the quote length, right, like this. We could come in and go string .len and then throw a quote inside of there, and then make sure we separate everything with commas. And you can see right there the quote length comes back at 111 characters. And we can come in here also and see that we can just go like this and then throw the number sign inside of there and get exactly the same result. This is the most common way to check the number of characters that you have in your string, by the way. You could also come in here and replace certain strings. So let's say that we wanted to replace, and this is going to be bad English, but replace I with me, for example. We could then go string dot gsub like this, and then you're going to put inside of there the string that you're going to want to change and the value that you're going to want to change, and then the value you're going to want to replace that with. So we'll say me instead like that, and always make sure that you close off all of your brackets, so make sure you have a closing one for this one. And file save and execute. You're going to see right here, replace I with me, and it went and changed all of the versions of I inside of this great big giant string to me instead. So it says me changed my password to incorrect and da-da-da-da-da. Another thing that we can do is find any matching indexes. Everything inside of in regards to strings is going to have an index, every character. So this is going to have the index of 0. This space right here is going to have the index of 1. This is going to have the index of 2. And we'll be able to search through this great big giant long quote and find out exactly what the index is. So we could say something like index of the word password, and we're going to use string.find. And again, we're going to pass in the string that we are going to be searching for, and then the word that we're going to be searching for, which in this situation is going to be password. And make sure we put a little comma inside of there, and you can see right here index of password is 14, so that's 14 characters into our great big giant long quote is the location of the word password. And two other little simple things we can do. Let's say that we wanted to make all of these characters inside of our quote uppercase. We could just put string upper, or lowercase we could just go string.lower. Save that, execute, and you can see right here, made everything uppercase and everything lowercase. Now we're going to get more into strings here in a second, but let's go and jump in and take a look at looping and how that works inside of Lua. I'm going to start off with a while loop, and what we're going to need to do is initialize or create a variable that is going to define the starting value that we're going to be looping through. And then we're going to say something like while I, the value of I, is less than or equal to 10, we want to continue looping through or executing code inside of our while loop. So let's just say we got IO right, and we just want to print out the value of I. There you go. And inside your while loop, you're of course going to have to increment the value of I. Remember, we can't do something like this, not allowed. You have to type everything out. And then let's also say that we would want to jump completely out of this loop and not continue looping through it anymore. If, for example, I has a value of 8, well then we're going to say something like break. And of course we have to put an end right there that's going to end our if statement, but then we're going to need another end that is actually going to end our while loop. And then we could do something like print and throw a new line in there. You're going to see if we execute that, it's going to print out 1, 2, 3, 4, 5, 6, 7, and it didn't continue printing up until 9 and 10 because right here we said if it gets to the value of 8, we want to jump outside of the loop and stop executing altogether. Also very important inside of Lua to understand, there is no continue statement. So you might be used to that in other programming languages, but it's not going to work here. Another thing we can do, and this is more like the common do while loop in other programming languages, we have something else that is called the repeat statement. So we're going to say repeat, and we're going to continue to execute code inside of here as long as a condition is true. And let's come in here and also demonstrate exactly how you can get user input from somebody. So we'll say enter your guess like that. We could then come down and store inside of the variable guess whatever they enter in the keyboard, and that is how easy it is to get keyboard input, just io.read. And then you're going to come down here and you're going to define the condition that this is going to continue looping. Now we're going to want to convert the guess that they made. It's automatically going to be stored as a string, so we want to convert it into a number. Remember, if we want to convert two strings, we type in string like that. But in this situation, we want to convert it into a number. So we're just going to put guess inside of there. And then we're going to say equals to 15. So this is going to be a little number guessing game in which it will continue asking them for a guess until they enter in 15. We type in that, and there we are, enter guess. And you can say 10, and it's going to continue to ask until 15 is entered, and then it's going to exit. So that is how to convert to numbers, and that is how to use the repeat until, or what is commonly known as the do while. But inside of Lua, it's known as repeat until. Now let's take a look at for loops, and they're a little bit different. What we're going to do, we're going to define an iterator, just like we did with the while loop previously. And we're going to give it a starting value, then we're going to give it an ending value, and then we're going to say how much should it increment each time. And we're going to put a 1 inside of there for that. You can put a 2, you can put anything. Let's go and print the I statement. You could also throw a break statement in there as well, and you can go ahead and check out exactly how that would work, and you can see it just cycled through there and printed out 1 through 10 right on our screen. Now what I'm going to do is, this is a table which we're going to talk more about here in a second, but it's basically like an array in other programming languages. It's just going to be a variable that's going to allow us to store multiple different values inside of it. And I jumped ahead to this right now because I want to show you how easy it is to cycle through all of these different tables. So here we'll just go for, and then we'll say key, K for the key. Let's just call it key, just so you can see, and value, because everything in a table is going to have a key or a value, or it's going to have an index by default if you do not assign a key. And we could say something like pairs. Pairs doesn't matter. You can put anything you want inside of here. It doesn't matter what the name of that is. And we could say months, and then we could say do like this, and then we could cycle through our table just like we did cycling through indexes. And let's just say in this situation we just want to print our values out to the screen, and of course we have to end our for loop right like this. And of course make sure that we put value inside of there and not v, and if we execute it, you're going to see that it prints out all of the different months with a space in between each one of those months. And of course we're going to be able to do more interesting things with tables and things like that, but this is just a quick way for me to demonstrate all those things. And since I brought up tables, why don't we go take a look at how a table works. Now basically, as I said, tables are going to take the place of arrays, dictionaries, tuples, and such in other programming languages. And how we can create a table is just go in here and say something like a table, and then put 2 curly brackets like that. There you are, there you have a table. We could come in here and add values to the table using a for loop. So we can add them just on their own, but this is just a quick way to throw a whole bunch of values inside of there. So we'll say a table, and everything is going to be stored inside of an index. So this is going to increment through different values of I, and it is going to just assign those values to I, and this is the index. So the very first index in our table is going to have the value of 1, just like you can see right there. And then of course we're going to end that. And we're going to be able to come in here then and access those using the index that we assign. So let's say we want the very first value stored inside of their index. You're going to see that we have 1 there, once again because we assigned it that way. Could also be 0 or it could be anything else. And you can see first comes back as 1, right, like this. So that's one way to access values inside of a table. You could probably guess exactly how we would find out the number of items that we have inside of our table. Let's just come in here. Why don't you guess? Okay, time's up. And let's just put a number sign and table inside of there. And that is exactly how we're going to be able to access those values. And you can see number of items is equal to 10, just like you may have thought. We could also come in here and insert a value inside of a table. We're going to put table. Don't let this confuse you. A table is the table. Table is the library we're going to use here. And if we want to insert a value, we just go table insert, define the table we want to insert into. We then define the index that we want to insert into, and then the value we would want to insert. And there you can see it didn't do anything. Let's go and print that out, and then you'll see it. Go like this, and first, and let's just let that set for 1, and we go like this, and now you can see the value of the first index inside of our table is now 0. Could also come in here and change this to 10. You can see everything was moved up as well, so there's 9 instead of 10, which would have originally been set for. We could also come in here and take a table and convert it into a string, and then define how we want all the different items to be separated. Let's just use print again here. How we would do that is table, concatenate, or combine, same thing, and table. And then we could define how we want all those items to be separated. Let's say we want to be separated with a comma. Could do that. Come over here, and there you can see exactly how that prints out. You can also see the zeros in there because we inserted it in there. Another thing we can do with tables is remove an item at a specific index. We would just go table, remove, and define the table we want to remove and the index we want to remove from. Copy this just so we can print this out again, and you can see it went and removed the 0 out of there. And we could also come in here and create multi-dimensional arrays. So let's go multi-dimensional tables. Sorry about that. Again, we're going to create our table right like this, and we'll use a for loop to come in here and populate this whole entire thing. So we'll say 0 through 9 do. Then we'll go multi-table like this. We're going to define an index we want to save inside of there, and that is also going to be a table. Create another for loop that is going to also populate this guy. So we'll go 0 through 9 again and do, and then a multi-table, and we'll say I, and you're also going to be able to come in here and pull values from these using exactly the same thing. Let's say we want to store them as strings, toString, I, and then we want to also throw I and J inside of there just for the heck of it, and then we can go end, and then finally end this for loop. Now we're going to be able to come in and access the values that are stored inside of there, of course, by using the indexes as well. So let's say table, and we wanted to get whatever is being stored at the index of 0, 0 inside of our multi-dimensional array. Go like this, or multi-dimensional table, sorry about that. And we can get 0 and 0 like this. And you can see it comes back as 0. Of course, we could come in here and go 1 and 2, save that, and you get 1 and 2, right like that. That's how everything is stored inside of the multi-dimensional array. And like I said before, we're going to use pretty much the same exact format for our for loop, as you can see right here, to cycle through and print out all of the items inside of our table. Make this, and you can see that every item is printed out there right there on our screen and exactly how they are formatted. Go like that, and you can see the 0, 0 index, so this is the 0 index for both of them, and the 0, 1, and so forth and so on. And you can go through and play with that and get a little bit more aware of exactly how tables are set up inside of Lua and exactly how to use them. So now let's jump over and take a look at functions. Okay, so a function is going to allow us to reuse our code as well as better organize our code, and we're going to just create a function by just typing in function, and then we give it a name like getSum, something like that. And if you want to pass values into a function to perform operations on them, we can do something like number 1 and number 2 like that. And if you wanted to perform an operation and then send it back to whoever called for our function to operate, that is exactly how you would do it, and then you would type in end. We could then come in here, and I'm bouncing back and forth between using print and the write command just to show you how to use them. And we could do something like 5 plus 2 is equal to, If we want to put a decimal inside of there, we just put a % and a D like that. And then we would call our function with getSum like that, and then pass in 5 and 2, separated with a comma. And there you can see our answer and exactly how we're able to call that function. Now let's come in and create another function. Let's have this one called split string, and it's going to receive a string passed into it. We're then going to create a string table like this. See, I said I'm going to keep coming back to all these different things. Want to define a local variable inside of this, and then let's cycle through the string and store anything except for spaces inside of our table. How would we do that? Well, we would go for and our string in, and then we would type in string dot gmatch, and then pass in the string that was passed into our function, this guy right here. And then if we wanted to basically capture all the strings up until the point in which there is a space, what we're going to use is a %. This is going to represent the beginning of a string or a bunch of characters or numbers or whatever. That's what this little caret symbol represents. And then a %, and S. This is what is known as a regular expression. I have tutorials on regular expressions, and I'm probably going to do another one here pretty soon. So basically what we're saying here is we want to cycle through the string that they pass into our function, and we want to start capturing characters up until we reach a space. And that is what we're going to be storing inside of our string table. You're going to see here as we execute it exactly how that's going to work. So we're cycling through the string. We're going to go string table and I for the index for our table, and we're going to be pulling out each of those strings and storing them temporarily in a variable named str, and then we're going to save them to our table. Then all we need to do is increment our value for I and then end. Okay, so we have all of those set up, and now let's also show you how we can return multiple values from a function. We would just go return, and we can return our string table, which is going to contain a bunch of values, but then we could also send back the number of matches, the total number of words that we found inside of our string. And maybe this might make more sense if we typed in word right here, and then we typed in word right here. So either way it works, and that's the way it operates. Then of course, the end our function, we put end, and then we'd be able to return or receive those multiple values that are returned from this function right here called split string by just going split, let's just say string table. So this value right here is going to be stored in this guy right here, and then the number of strings inside of there, or number of words, whatever you want to call it. And then we just call our function like this, and let's just keep it simple, and let's just say something like turtle. Let's just pass in 2 of those guys. We could then come in here and cycle through everything that was passed back inside of that table. Go 1, again, number of strings. We're going to keep cycling through there. This is the maximum number of strings, and that's the maximum amount we're going to loop through. Do. And then we could print out on the screen. Let's go and format this guy, and we could print our index separated by the individual words that were also passed back inside of there. So let's get J, and then we'll go split string table, this guy right here, and then throw the index inside of there. And then final thing we have to do, of course, is end our for loop. And if you went inside of there, you can see that it returned the and turtle and then nil. There's always an extra little nil inside of there whenever we create tables. And we could of course get rid of that by just going number of string -1, and you can see that it just prints out the and turtle. So that's how to go in, call a function, how to have it return multiple different values, how to split a string into a table, and how to return that value over here and save it into multiple different variables and then cycle through it. So there's a whole bunch of different ways we can use functions inside of Lua. Let's go and talk about Variadic Functions. This is how we're going to be able to receive an unknown number of parameters inside of our functions. Again, just create a function, and let's just call this get some more. If we don't know how many different parameters or attributes or whatever that could be sent inside here, we're just going to put 3 little dots inside of there. And we could do something like local sum is equal to 0. We could then come in and go for, and this is the key, and this is the value, once again, in pairs. This is going to be passed in here as a table. Then we're going to put curly brackets, 1, 2, 3. It's going to automatically just keep cycling through there depending upon the number of attributes or parameters that were passed inside. Then we go sum is equal to sum plus whatever value was passed inside. Of course, end that with an end. Then after it's done, go return the total sum and then close off the function. And then we could print all this out on the screen. Call get some more. You're going to be able to pass as many things in here as you could possibly ever want to. Let's just keep it as 6. And it gave me a little bit of an error. You can see right here, get sum. I can type in sum more like that, and there we go. Sum is equal to 21. So that's how we're able to pass in an unknown number of parameters and then use it. Now, another thing that's kind of interesting inside of Lua is a function is a variable in that we can store them under variable names as well as we store tables, and we can also pass and return them through functions. So let's demonstrate that. Let's say double it. There is a variable. We can actually put a function inside of this. So let's say it gets a value of x, and then we can just say return x times 2, and then put the end function on there. So we have basically just made double it a function. It is a variable also, however. You can see right here, if we just go print and double it like this, and then pass in a 4, it's automatically going to pop out an 8. Now, going along those same lines, a closure is a function that can access local variables of an enclosing function. So let's go and let's create one. So let's go function. Let's just call this outer func, because this is going to be an outer function that is going to contain our closure. You're going to see exactly why this is interesting. So let's create a local variable, I equal to 0. And then let's put an inner function inside of it. So return function like this. And then inside of this guy, let's go and increment the value of I, and then return. So this is a function inside of a function. This is a closure. And the reason why it is a closure, we have to end this, and we also have to end this one. Now, whenever you include an inner function in a function, that inner function is actually going to remember any changes made to the variable inside of the inner function. Now let's go and let's store our function inside of a variable called getI. So we'll go outer func like that. So there we stored it inside of there. Now what we're going to be able to do is go print getI like that, and it's a function, and then do exactly the same thing again. The reason why this is a closure is you're going to actually continue to increment and store the changing values of I that are inside of here, as you're going to see right here. And there you can see value of I is starts off as 1, but then whenever it's called a second time, it is going to increment it, even though we assign the value of 0 right there. So that's an example of a closure and exactly how they work and how they store values as they are being called multiple different times. So now let's go and take a look at a similar thing, which is called a coroutine. Now, a coroutine is very similar to a thread in other programming languages, except that they cannot run in parallel. And a coroutine is either going to have a status of running, suspended, dead, or normal, and you're going to see what all those look like. So let's create a coroutine. How you do that is by just coming in here and going coroutine, and we're going to say create. And inside of this, I'm going to put a function. And then inside of this, I'm going to say for I is equal to 1, give it a starting value. And 10 is going to be the ending value. And 1 is going to be the increment. And then inside of this, we're going to say print I, value of I. And also, let's go print coroutine status, just so we can see the changing statuses from running, suspended, dead, or normal. How we do that is pass in coroutine name inside of there. Close that off. Then we can say something like if I is equal to 5, then, and if we want to pause or yield over to another coroutine, we just type in coroutine yield, and then we're going to end our if statement. And on the next line, we will end our for loop, and then on the next line, we will end our coroutine. So there we go. Have all those saved. Maybe it makes a little bit more sense. Come in here and go like this and like that. Now, if we want to come in here and check our coroutine and see what its status is whenever it very first starts, we'll just go coroutine status like that, and exactly like this. And you can see it starts off as suspended. Now we can call for this coroutine to resume or start executing, and then we can come in here and also check the status after we tell it to start running. And you can see it starts off as suspended, starts coming out here and printing out all these numbers, and it comes right up to 5, and you can see it's also technically running right there. That's the status until it hits 5. And the reason why is it says if I is equal to 5, we want to yield this coroutine and stop its execution. Now let's come in here and create another coroutine that we're going to run at the same time, very much like we would do with threads. It's equal to coroutine, and we're going to create one. And this one's going to go function, create a function right inside of here, create another for loop. We'll go I is equal to 101. You can start it off at 101 and have it count to 110 and increment by 1 and do. and print whatever the value of I is each time, and then end our for loop as well as end our coroutine. And now we can see that if we go in here again and go coroutine resume like this, let's just have this be CO2 like that, but then also do exactly the same thing or restart or continue execution inside of our original coroutine that we created. And you can see the process here starts off as suspended, gets up to 5, running, then it gets suspended, jumps over to the other coroutine, which doesn't get suspended or doesn't have to yield its time at all, goes through its entire process, and then whenever we call the coroutine to continue execution, you can see that it continues executing until it is finally dead. And you can see right here, if we come in and get the status of this coroutine right here, it is in fact dead after it has done or executed all the code inside of it. So there's an overview of coroutines. Now let's take a look at something that a lot of people are confused about because there's not much good information online about it, and that is file I/O. Now there's many different ways that we're going to be able to operate on files, and you can see all the different ways right here. We're going to either be able to have the file set as read-only, which is the default. We're going to either overwrite or create a new file, which means we're going to append or create a new file if this is used. This is used for read and write of an existing file, overwrite, read, or create a new file, and then append, read, or create a new file. I'm going to come in here and actually start opening files and storing things inside of them so we can see exactly how this operates. If we want to create a new file that we're going to be working with, we just go IO, open, right like this, and then we're going to give it a name. Let's say I call this test Lua, like that. And let's say that I want to have the opportunity to create a new file because I know this doesn't exist right now, and then I want to also be able to overwrite and read from that file. So I'm going to just use that guy right there because that works for all the things I want to be able to do. And there you go. You just created a file and you're able to write to it and read from it and also make it. Now if we want to come in here and write some text to the file, we just go File, Write, and then we'll say random string of text. And we can use new lines inside of here for our files as well. And let's say we want to put some more stuff in there. So we'll say write again, and we'll just say something like some more text. Throw another new line inside of there. We can use seek now to move back to the beginning of our file by going File, Seek, like this. And then we're going to type in set, and then the index where we want to jump because everything is indexes inside a string. So we want to jump back to the beginning of our file, and that's how we do that. And then if we want to go and read everything from our file, we'll just go File, Read, right like this. And then we'll put a star inside of here and an A, meaning that we want to read everything from our file. Okay, so we wrote to our file, we created our file, we jump back to the beginning of our file, and we're going to read everything from that point. Final thing we need to do is close our file. And there we go. And it popped up a little bit of an error. I keep the errors inside of here. Just want to make sure we put our quotes inside of there because I think whenever you see me make an error, that's going to help you keep from making errors. And you can see right there, printed out, random string of text, and some more text right like that. Now let's say that we wanted to come in here and also continue working with our file, but we want to append data to the end of our file. How do we do that? Well, we can just leave this named as file because Lua's real nice about stuff like that, and we'll just say IO open, and again we're just going to type in the name of the file that we want to work with, and then in this situation I want to append, so I'm going to say A plus like that. I can of course come in and write some new information to our file, and let's just say even more text. Again, remember, if you want to read from a file, you have to jump back to the beginning of it. So we're going to use seek to do that. And we're going to say set, and then we're going to say exactly where we want to jump to. You can put any index in here to jump around all over inside of the file. And then we can say print, and of course we're going to read data from our file, and we want to get all of that data inside of there, right like this. And then finally, we want to close our file. And if we do all that, you can say random string text, and then some more text comes in there, and then even more text gets printed out on our screen. So that is how we're going to be able to work with our files inside of Lua. Now let's take a look at modules. Okay, so basically a module is like a library that is full of functions and variables, and you're going to be able to create it and then use it inside of your program. So let's go and let's create a module. So we'll just come in here and go new file, and I am going to save this guy using the name convert.lua, of course, and then save that. So let's create a module. And it's very important that your module name and your file name are exactly the same. And to create one, I'm going to go local convert, the name of this guy, and there is our module. And then inside of this I can put a function. Let's say I want to do something like convert feet to centimeters. So we'll go feet to centimeters, and this function is going to receive an attribute of feet, and then it is going to return whatever that value is times 30.48. I think that's right. And end, and then you also need to return the module and save it. And that is how we're going to do it. Just make sure we have convert here, and convert here. Very important, and also the name of the file has to be converted or convert. Well, now we can come over and do something like convert module. It doesn't need to be named convert module. You can name it whatever you want. And if you want to be able to get access to that, they have to be in the same directory, of course. We're going to say require and convert, right like this. And then we'll be able to come in here and work with this module function. It's this, and then let's say that we want only 3 decimal places. That's how we do that with a floating point number, and there is centimeters. And then if we want to call our module, just convert module, just like we created right there. And then follow that with feet to centimeters, which is the name of the function we have in the module. And we can pass in a value of 12, and you can see it gets back the answer of 42.480 centimeters. So there's a quick example of how we can work with modules inside of Lua. Now let's take a look at metatables. Now a metatable is going to allow us to define how operations on tables should be carried out in regards to adding tables together, subtracting, multiplying, dividing, concatenating, comparing tables, and so forth and so on. So let's come in and create a table and put some default values in it. So I'm just going to go a table like this and create my little table. And then I'm going to use a for loop to jump through here and just fill it up with stuff. Let's just say 1 through 10, 2. And a table, and of course we're going to use the same indexes here and just store whatever the value is inside of there. Of course, close that off. So there we go, we got a table. Now we're going to define our metatable, and how we're going to do this is go empty, and then we're going to define how table values should be added. And you're going to be able to define, like I said before, adding. You're going to be able to also define how tables should be subtracted, how they should be multiplied, how they should be divided, how they should be, if you want to use the modulus, and how they should be combined, which is the same as this guy right here, which we've talked about previously. I'm just going to focus on a couple of these. So I'm going to go add. There's 2 spaces right here, by the way. There's 2 underscores. All right, so we're going to define how these are going to be added together. We're going to go function, and we're going to say if you pass in table 1 to tables, I'm going to define here exactly how they are going to be added together. I'm going to create a sum table like this, which is going to be the table that is going to be returned. And I'm going to go for y is equal to 1, and I'm going to cycle through the number of tables that we have right here and just do that for me. And then let's say that I want to also come in here and check to make sure that the table values are not equal to nil. Well, I can just go table 1 like that and get the value of that is, remember, it's the tilde sign, not equal to nil. Can do that. And both of these have to be true for this to work. I can say table 2 and then also put the y inside of there, not equal to nil. Well, then I will do some stuff. Well, make sure that we put this guy over here, close that off, and then put then. There we are. Open this up a little bit better. What am I going to do if I got what I need here? Well, I'm going to start adding stuff to the sum table. So sum table, the value is going to be stored inside of the same exact index, is going to be equal to, and this is just what I decided how I want to, you can decide how you want to add table values anyway, but this is the way that makes logical sense to me. So table 2. So I'm going to take the values that's in 1 and 2 and then store them inside of a brand new table, this guy right here. Else, let's say that one of these came back as nil. What do I want to do in that situation? Well, I want to say sum table y, and let's say that I want to store 0 inside of there. I make the rules in this situation, so that's how it's going to work because that's how I decided it'll work. And we want to close off our if statement, and we want to close off our for statement, and then after we have created our brand new table with all those sums inside of it, I want to return that guy right there, and then I want to end this. I'm going to say end, and then I'm going to put a comma right after that. Now I can also come in here and define how table values are going to be checked for equality, and how we can do that is 2 underscores again, put EQ inside of there, is equal to function, and I can go table 1 and table 2 like this, and then I can just go return table 1, get the value inside of it, and make sure that it is equal to table 2, and get the value out of that as well. And if both of those come back, then we know that that is going to work for us. Then of course we have to come in here and we want to end this guy right here. So go end and a comma. Another thing we can do is we can also check if it is less than. And I'm going to let you use that as your homework assignment to figure out exactly how to make sure that these values work for whether a table is less than, or also if it's less than or equal to another object right there. And then also figure out exactly how subtraction and multiplication and division works. Hint, 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 it's going to be something very, very similar to this guy right here. Okay, so now that we have our meta table all set up, we need to attach the meta methods to our table. How you do that is go set meta table, and there's the table we're going to assign it to, and there is our meta table. So set meta table right like that. And then we can come in and check if they are equal. So a table is equal to a table. That's going to work, of course. And it had a little bit of a bug up here in the a table. Change that to uppercase right like that. And then down here inside of the equality check, make sure that those are equal. Fix that. And if we do that and execute, you're going to see that this comes back as true, just as you may have thought with this right here. And now we're going to test what we did in regards to adding tables. So we're going to create a new table called add table, and then we can go add table is equal to, and then we'll just pass in a table. We can pass in different ones, but it doesn't really matter. And a table, and you've seen this before. We can just create a simple for loop that's going to allow us to cycle through our new add table we just created right here, and whenever we execute it, it's going to add all those values together in our brand new table and print them out on the screen. So there's metatables and meta methods and how we can work with them. Now let's take a look at object-oriented programming, or at least Lua's version of object-oriented programming. Okay, so just so to make this very clear, Lua is not an OOP language, and it doesn't allow you to define classes, but you can in some ways fake it using tables and metatables. So what we're going to do here is we're going to create an animal table right like this. And I'm going to define all the default values for everything inside of it. So we'll have a height and a weight equal to 0, and we'll also have a name. The default name is going to be no name, and then we'll also have our animal type of objects, also have a sound. Let's just have no sound. Okay, so there is the table we have created for animal, or the object that we're trying to create inside of here. Now we have to define a function for our table that's going to allow us to initialize this guy. And how we do that is with function animal, and I'm going to give it the name of new, and it is going to receive a height, a weight, a name, and a sound, very similar to an object-oriented programming language. What we're going to have to do now is set our meta table, and we're just going to throw in a junk table right there, and then animal right there. So that's how simple it is to create that meta table. Now, if we want to refer to height, weight, name, and sound for our animal objects, we use self, because we don't know what the name of it is. So we're going to say like this, and we'll just go and create that. Then we need to do that for all of the other different attributes we want for our animal objects. So we're also going to have weight, and change this to weight, and then we're going to have name, and then finally sound. So we're creating it in very similar ways to what you have seen in other programming languages. And this is going to initialize or create a new animal object, and after it initializes everything, it's going to return that animal object. Of course, end the function with end. Say we wanted to come in here and also create a function that is going to allow us to print out information about our animal object. Let's call it toString. It's not going to receive anything. And we can then go animal string like this, and string. This is another way of using string format that I haven't showed you. And we could just go $s, weighs, and then let's get a weight for our animal. Pounds is $f, inches tall, and says, and let's get the sound that it's going to make. Then if we want to import all those things for our specific animal object, we're going to go and get the self name and self weight and self height, and then whoops, make sure we do this right, self height like that, and then finally self sound. So that is a way for us to import all of those specific things for our animal into the toString function here. And then we can just go return animal string. and end that function. So this is an object function inside of here, and this is how we initialize it, and this is all the defaults and the metatable we define for it. So it's all very, very similar to things we've seen in the past. So let's go and create an animal object. Let's call it Spot. How we do that is we would go animal, and we call our initialization function, and let's just pass some junk values inside of here. There's his name, and then his sound. Let's say his sound is wolf because that makes sense. Okay, so we just called for our animal object to be initialized. We could then come in and go print spot weight like that, and then we could also go print spot, and then if we want to call the function, we just go toString like this. ToString, it doesn't have to have that name, it's just the name I gave it. Said it was unexpected. Let's put this quote inside of here. That should fix it. And there you can see it works. So 15 comes out. That is how we're accessing the weight with the dot operator, right like this. And then we can call that function, which is automatically going to get all that information about Spot and print it right there on our screen. So you may ask yourself, well, does inheritance work inside of Lua? Well, yes, it does, and this is how we're going to use it. So let's say we want to create a brand new object called cat. We can inherit all of the functions defined inside of our animal object just by calling new, right like this. There we go. Now we have we have the toString, we have the height, weight, name, and sound, all that stuff inside of our new cat object. We can, of course, come in here and overwrite any of the functions. So one of the functions we want to overwrite, let's say we want to overwrite new, and how it works inside of our new cat objects. Well, we're just going to come in here and replace animal with cat. And let's say that our cat objects are also going to store in favorite food and not just height, weight, name, and sound. Well, we're going to set our metatable here to be cat instead of animal. And then the only thing we need to change down here is to come down and grab this guy right there, throw that down, and let's get favorite food, and let's also store that inside of it, right like this. And it's going to return, and everything's going to work exactly the same. We could then also come in here and override our toString function if we'd like. Let's go and get this. Remember, we just changed this cat new instead of animal new. Throw that right there. And we're going to do the same sort of thing for toString. We're going to say cat toString. And then how this guy's going to change is we're going to say something like says whatever and loves. And let's get his favorite food inside of here. So there that is. We'll just go self favorite food. And now let's come down and create a cat. So let's call it Fluffy, and we'll just call it with cat new, just like we did before. And let's just keep it simple to 15 Fluffy. Fluffy says meow, of course, and Fluffy's favorite food is tuna. And of course, we're going to be able to come in here and go print Fluffy to string, call that function. And you can see Fluffy weighs 15 pounds, 10 inches tall, and says meow and loves tuna. So there you go, guys. There is a ton of information about Lua. Hope you guys found that interesting. Of course, in the description is a link to all the code and a cheat sheet, as well as links to all of the individual pieces I talk about Lua. So please leave your questions and comments below. Up next, C#. Otherwise, till next time.